Thank you guys so much for having me. I'm very excited to be here talking about our data science journey and our entire data architecture journey at Zefr. So, as was said, Zefr is a video ad tech company. So I'm going to start, before I get into kind of how, I'm going to start with myself, actually. So my name is Jon Morra. I'm currently the VP of Data Science at Zefr. I have a PhD in biomedical engineering from UCLA. After I did that, I worked briefly as a dev, decided I didn't really like that. I actually had my own company doing machine learning methods in radiation oncology. After that didn't work out. Around 2013, I looked around, I knew machine learning, I knew development, I decided to just call myself a data scientist, where I started at eHarmony, worked my way up to lead machine learning efforts there, and then I moved over to Zefr in October of 2016, where I've been since. So we're just going to go a brief history of advertising in general. So advertising works in an implied contract between the person who's seeing the content and a brand who wants to advertise. And it's a free interaction, and this has been understood for a century at least, dating back to newspapers, radio, and up through TV. And when you wanted to advertise in those mediums, the only way to reach an audience was through a specific type of content. A radio program, a magazine, or a TV show. You couldn't reach the person individually. With the advent of the internet, though, that all changed. All of a sudden, you could do audience targeting. And I'm sure everyone here has had this experience where they're on their phones and they see an ad and they go to their apps and they see the same ad and they go to their computer and they see the same ad. This is audience targeting. And really what's happened is the pendulum has swung very, very far in the ad tech world towards audience targeting. And what we're seeing is a backlash against that right now in the field. And this really started, and this is especially true on video advertising, I say, because unlike in banner advertising, where most people have been trained to ignore the ad, when you see an ad on a platform like YouTube, you really have to watch it. I mean, there's really no way to cover your ears and your eyes and not watch the video before the video you want is played. So this started in the UK, this backlash, around 2017. And what brands were seeing was their content was around some really bad stuff. And a term was coined for this called brand safety. And we see big, giant brands like AT&T not on YouTube, the Wall Street Journal talking about brand safety concerns, and a bunch of other specific journals talking about how this is really, really bad. And this content is obviously bad most of the time. It's pornographic content, terrorism content that's unfortunately pervasive on YouTube, but people have to advertise on YouTube because the eyeballs, especially the young eyeballs, are all there. And in addition, what we've seen is lots of studies talking about how content or context alignment is really, really beneficial and actually makes a message hit home. And I'm sure some of you in the audience have had this experience too. When you're going to watch a video, you're in a certain mindset. So a certain type of advertising is probably, you're more susceptible to that. And so what Zefr does is content targeting on YouTube. So Google knows about the audience. We try and supply the best content. So we identify the content on YouTube, we filter it, we filter all the videos, and we organize them into ideas that somebody might want to buy, a brand might want to buy when they want to advertise. So with this, I'm going to go through kind of 3 different journeys throughout this talk. One is our data architecture right now and how we got there. A lot of mistakes we made along the way. The next thing I'm going to talk about is data science. This is what I work on day to day. A couple of problems that we deal with on the data science community, or the data science side, and finally, our data science architecture. So let's look first at our overall data architecture. So we at Zefr are probably the single biggest consumers of the YouTube API in the world. If you, as an individual, want to go out and ask the YouTube public API, you can definitely do that. You can ask for 100, 1,000, 10,000 videos, maybe even 100,000, and not worry about it. We want to know about all the videos on YouTube. So this is a long process. And so we've made use of this public API for at least 5 years, long before I was employed at Zefr. And the way that we used to do this was search-based. And a lot of our technology is still search-based. So an advertiser would come to us and say, we want to advertise on a particular topic, like luxury cars. And we'd say, great, we have a handcrafted search, and we go out and find videos on YouTube that were luxury cars. We'd be like terms like BMW or i3 and not Peppa the Pig, because you need to add and not Peppa the Pig to every search you do on YouTube. But this got very expensive, and we were redoing these searches all the time because search was coupled with a specific business need. So what we did is we decoupled them. We came up with this technology we call the Media Discovery Engine, or MDE, and really what its job is to do is to comb YouTube and discover all of the videos on YouTube and archive them. So stuff like the blank search was highly effective in discovering videos on YouTube. We had all these highly crafted searches that we run all the time. We use the related video graph to help find every video on YouTube. And really what this enables is me to even do my job. If I had to go to YouTube every time I wanted to ask a question about videos, it's cost prohibitive. There's something called a quota, which says how often you can call the API. We would blow it up, and YouTube would shut us down. So this is our current technology stack. We make use of Kafka for our message passing infrastructure. We actually came from Kinesis, which is an AWS product, and found that it didn't scale well enough. We make use of Elasticsearch as our serving layer right now for our videos, and this actually has worked beautifully so far for us. Currently, we use Snowflake as our data warehousing solution. This is actually very, very new within the last 15 days, and I haven't been at work in the last 10 days, so I'm not sure exactly how it's going, but I think it's going pretty well. The POCs went very well. We switched over from Redshift. We tried Athena. They just weren't as effective as our Snowflake POCs. And finally, we use Apache Avro as our message passing format. So for those not familiar with Avro, you can think of it as a type-safe JSON. It's analogous to Google's protocol buffers or Thrift or ORC, if you guys are familiar with any of those technologies. And so the first thing that we do in our data architecture and our data engineering is we want to discover, like I said, all the videos. We actually don't know how many videos there are on YouTube. To the best of my knowledge, Google stopped publishing such metrics a couple years ago. And frankly, even if they did, they wouldn't really mean a lot. I can tell you, we at Zefr know of about 3.5 billion unique YouTube videos. From that, we create a working set, what we call the monetizable set, of about 100 million. These are videos that we think are capable of running an ad. And I should say that a video is highly mutable. In fact, everything about a video on YouTube is mutable except for the actual video itself, the pixels and the audio. And so what that means is when we know of 100 million videos, that's currently in our monetizable set. We observe 120-ish unique videos a day. Most of them we're just re-observing. We know their IDs. We ask again, what is it here? What's the new values? What's the new values over and over again? But we discover about 2 million new videos a day too. So I've talked a lot about a video. So I'm gonna go and describe kind of what exactly a video is. And again, this is translated into an Avro schema that we can look up in our GitHub at any time. So obviously we have the video itself. We have stuff like the duration, the title, the number of views it has. This obviously changes all the time. The channel and publish date. Each video belongs to exactly one channel. A channel can have many videos. Its description. The comments, which are really difficult to deal with. The video thumbnail. This is a user-chosen way to look at a video, and this is actually very important. The video quality, whether it's high definition or standard definition, the likes and dislikes, and any related videos. And these are just some of the fields. There's actually a lot more. But this is, when I say a video, this is what I mean. So now I'm going to jump into a couple of data science problems that we think about here, and I think about, frankly, all the time. So first I'm going to talk about brand safety. When I started at Zefr, we did brand safety. We had to. Everyone did brand safety. It takes one advertiser having one bad experience, somebody at the Wall Street Journal taking a screenshot of Coke advertising in front of a ISIS recruitment video, publishes an article, Coke calls you up and says, I don't want to be a client anymore. That's awful. So we've been doing this for years. We had always done it based on search terms. So we'd have a naughty word list in English, and if any video matched the title or description, matched that naughty word list, it would be brand unsafe and therefore not be predicted against. Well, when I started, I said, how do we know we're doing a good job? In fact, how good of a job are we doing? No one could answer. People just say, oh, we have all the bad words you'd expect there. I said, great. how good are we identifying bad videos? I don't know. When I started as a VP, the reason I wanted that title so bad was so that I could have a seat in the executive room. The executives couldn't tell me how well they were doing. The frontline engineers couldn't tell me how well they were doing. In fact, they didn't even know how to measure it. So a lot of my first time at Zefr was spent purely on educating, like the scientific method. We need to have observations. We need to measure our quality. We need to have a consistent definition of quality. And once we were able to do that and think about that, we could assess how well our current search model is doing or how well any other model of detecting brand unsafe videos that we may derive in the future. So what we settled on was the fact that we have to watch videos, which seems obvious, but we weren't doing it, at least structured. We would watch a video, we'd say this is a bad video, it has this word, we'd add it to the term list. How many other videos did it exclude? I don't know. So what we did is we defined brand safety in 4 terms. Is it violence? Is it sex? Is it drugs? Or is it have really offensive language? And a brand unsafe video is the logical or of those 4 terms. Pretty simple. And so we watched a lot of videos. And that's what we do now. When we talk about brand safety, we have teams that just watch videos and answer these 4 questions, yes, no, over and over again. And after they answer all these questions, we have a clear definition of whether a video is safe or unsafe. And when we say brand safety internally, and I'll come back to this, a video is brand unsafe if it is inappropriate for all customers. So you might consider some video game violence could be appropriate for some of our video game clients, so that would not be an unsafe video. So the journey to actually watching videos was a very bumpy one. And we started doing this internally and got a lot of pushback. This is not particularly fun work. Sometimes it actually can be psychologically difficult because we're finding bad videos on purpose and asking people to watch them. So we tried to outsource this. We tried 3 different solutions. I looked at AWS's Mechanical Turk, I looked at Figure 8, and I looked at a company called TaskUs. So for those unfamiliar with those, I'll briefly. Mechanical Turk is a crowdsourcing platform that just matches people like me with work to contributors out in the wild who want to make a couple cents for their opinions. That's all that it is. It really has no data quality. It has no way to detect it. You know, if somebody's doing a good or a bad job, you have to control all that yourself. On the other end of the spectrum, TaskUs really provides employees, basically in other countries. They get paid reasonably well, at least by American standards, by Western world standards, and they get better. They're assigned to your specific task. So they would do your job, and you could have them do whatever you want, but you'd supply the tool that they would work on. Figure 8 kind of fits right in the middle. They're like Mechanical Turk, a crowdsourcing solution, but they provide this really nice data QC layer on top to tell if somebody's just spamming yes or spamming no, and helps us control for the quality of data we get back. That's what we ended up using. That's what we use today to help us with this brand safety problem. And really, the selling point more than anything was that it ensures high quality. I didn't want to have to think if somebody's watching a video and being adversarial or not doing their job. I wanted that to be outsourced to somebody else. And really, we need a constant stream of data for our problem to help control for drift. So drift, in machine learning parlance, basically means the distribution you're modeling changes over time. And if you guys aren't considering drift right now in your machine learning problems, you really should, because I don't know of any problems that are time invariant. So when we think of drift, specifically at Zefr, we think of drift in 3 different ways. 1, the videos on YouTube can drift. So something like the Ice Bucket Challenge was not a thing. It was real popular on YouTube, and now it's not really a thing, right? That kind of just YouTube changing. The definition of brand safety can change. A new drug could come out tomorrow that could be unsafe, and we have to change our definition to accommodate that. Or the larger zeitgeist can change. An example of this would be, I don't know if you guys saw the season premiere of SNL. Kanye West was on it, went a little crazy. So maybe Kanye West is no longer brand safe just because of the way he acted. Right? And so we have to control for that. And having a constant stream of data really helps us control for this drift. So we went ahead and used machine learning. So after we have a whole bunch of labeled data, this is pretty simple, pretty standard binary classification. And I'm actually going to talk just a little bit about the machine learning stuff. We used LightGBM for this, which is a gradient boosting machine. We made use of pre-trained word vectors, specifically glove, for our text embeddings. We made use of one-hot encoding for our categorical variables. And we played around with a bunch of different hyper-optimization frameworks, a Bayesian framework, and a random framework. And here are our first results. So this is the precision recall curve. And what we can see is the search-based model is really a point on this curve. And the reason the search-based model is a point is because if the video matches at least one term in the naughty word list, it's considered unsafe. So it's really a point on the PR graph, because we can threshold our machine learning model anywhere we want. And I should say that true here is unsafe. So this is really an unsafe detector. This is great. The exec team had no idea how to interpret this. And the product team had no idea how to interpret this. So a lot of my job is making this stuff more interpretable and making it more actionable. So what we did is we worked with the product team and said, okay, great. We have to change this algorithm that outputs a floating point number between 0 and 1 into a decision, a binary decision, whether a video is safe or unsafe. So what I agreed on with product is how much of our inventory, of all the 100 million videos, could we lose and still satisfy our customers' need? Came back with 23%. So I said, great. If we threshold at 23%, which is that vertical line, the number of videos retained, here's our precision and recall. And what I did, and I've convinced many people over and over and over about this, is this is a high recall problem. Right? So recall, in this sense, is what is the total number of unsafe videos that I find? Because that's what we want. We want to find all the unsafe videos in the universe and take them out of campaigns. 56%. If we go back, we can see the recall on our search-based model is 15%. So a drastic improvement. And really, this is celebrated internally because I was able to convince the management what we needed to measure and then show a clear improvement in an unbiased metric. I didn't tell these people how to watch videos. They just did it. So that's brand safety. So the next thing I want to talk about is another problem called content relevancy. And this is really about identifying brand preferences. If you remember what I said before, a video is brand unsafe if it's bad for all customers, excuse me. Content relevancy is really everything else. The act that a lot of our customers want to target specific videos. So I'll give you a couple of examples. A simple one. A shoe brand wants to be around NBA videos. Seems kind of obvious. People playing basketball, want to target that. Some are not. This is actually a true story. We have a brand whose CEO just has a personal beef with Jimmy Fallon. Okay, he was on a show and he made fun of him, so his brand cannot be around any Jimmy Fallon videos. Why? I don't know. I don't care. That's not my job. But my job is to find Jimmy Fallon videos and make sure they're not in any of his campaigns. So I'm going to talk about two ways that we do this. So right now, this is in production today, and what we're hopefully trying to transition away from, and this is packages. So packages are a predefined set of concepts organized into a two-layer hierarchy we call packages and sub-packages that customers can go out and buy. So here's a couple. Packages are something like fall and autumn or family and children interest, Father's Day, and underneath Father's Day you see two sub-packages, Father's Day activities and Father's Day gift cards. So an advertiser might come to us and say, I want to be around fashion videos. We say, great, here's the fashion package. So by targeting fashion, you're also not targeting stuff like gaming. So one of the first tasks I worked on at Zefr was trying to map our packages and do the same thing we did for brand safety. So make them more measurable, improve the quality. And what I did was I found a public data set. So this is another kind of take-home tidbit, is that there is a lot of public data sets out there. And if you're not at least thinking about if there are any public data sets that can help you, I really would encourage you to do so. So we found one, actually published by YouTube, called YouTube 8 Million. This was worked on in 2017. Subsequently, YouTube 8 Million has released a second version of this exact task. And what this was is to further computer vision research, YouTube released about 8 million videos with their label. They have about 4,500 labels to choose from. And so at Zefr, we went and said, okay, could we use this as a seed to see if we could recreate our packages using Google's data to help validate if we were doing a good job? We found 255 YouTube 8 million labels that overlapped with Zefr packages, and so we assessed the quality. We used average precision because we didn't know the threshold, So that's the same. That's the area under the precision recall curve you guys saw before. And we combined it across the labels in an unweighted way. This is mean average precision. I tried 2 different models. TensorFlow with Keras. So Keras is a wrapper around TensorFlow. TensorFlow is a deep learning library. I spent 3 or 4 days with this. Ended up with doing a 3-layer network, an embedding layer, a gated recurrent unit. I tried LSTMs, I tried RNNs on the text. GRUs are the best, and then a softmax layer. Got a mean average precision of about 0.58. Tried Valpil Wabbit, which is a large-scale linear learner. It's incredibly efficient, and if you guys have large, sparse data, I really encourage you to check it out. It implements the hashing trick by default, which is just a really elegant way to avoid multiple passes over the training data. I got a mean average precision of about the same. I should say for Valpil, I used a 28-bit hash, so my feature space was actually pretty large. And there's a whole bunch of caveats that can be said here. I am an expert in Valpil Wabbit. I'm a contributor. Certainly not an expert in TensorFlow. There's new algorithms that have come out since then, a lot of promising research from Google and OpenAI and FastAI on transfer learning and natural language processing that I have not tried out, that I'm very excited to try out. But this was the experience I had. As part of the competition, people had to submit their results to win a prize at CVPR in 2017. And here are their results on the left. It's not as clear as I'd like. But they used GAP, or global average precision, which is a weighted combination of average precisions. We used mean average precision. What you can see is that for those teams that chose to self-report mean average precision, we were better. Whether or not that holds for all teams, I don't know. But this was the sample that I had. And to look at it, to figure out why, you can kind of look at a video like this, where this is James Corden on the right, or sorry, on the left, and Usher, he's a late-night TV show host in the States, and Usher on the right, he's an R&B artist. They're doing a bit called Carpool Karaoke. If you were just looking at the video, it'd actually be really hard to determine what they're doing. Maybe you could tell there's 2 people, maybe you could tell they're singing, they're driving, you can't really tell they're in LA. But the title says Usher Carpool Karaoke. It's very clear what they're doing. And so the take-home message here is that if you're only looking at the video, if you're only trying to do the fanciest of the fancy things, which is processing video, you're not going to get the right answer. The right answer is Usher Carpool Karaoke. That is the bit that an advertiser wants to buy. So make sure you use simple methods, simple features, simple algorithms when appropriate, and only use the complex ones when you need to. So now I'm going to move into kind of the project that I think about the most at Zefr, and that is custom targeting. So if you're an advertiser and you want to buy a general concept like a package, that's great. For some, that's not enough, though. So regulatory markets are a great example. Stuff like alcohol brands or pharmaceuticals or people that are very sensitive either towards or against kids. So you can think like Disney is sensitive towards its kids. They have a very specific definition of what they want that's either legal or internal regulation that doesn't fit our packages. And we don't want to keep building custom packages for everyone. We want to target what these people want. In addition, we know that short-term success in terms of advertisers does not necessarily lead to long-term success. So short-term performance is something like, did a user watch the ad? Well, that's great, but really what they want is, did you go out and buy their product? Or when you're at the movie theater, do you choose Coke over Pepsi because you've seen a lot of Coke ads? Right? And so it's more difficult to assess long-term performance. There's an old saying in the ad tech business that 50% of all advertising dollars are wasted. We just don't know which 50%. So, but as a data scientist, that's so unfulfilling. I want to go out and I want to have a signal that I can target, and I want to say, get out of my way, and I'm going to optimize this signal. And my product people keep pushing back and say, we don't know what it is, or it's different for every customer, or we can't even measure it sometimes. So this is another tidbit, is that constantly push your product people to help you define a signal and keep it as static as possible. What you're optimizing, if you keep it the same, you're going to be much, much happier. So because we can't do these ultimate long-term signals, we rely on the brands to tell us what they want, because they've done all the research, the market research. They know the content they want to be around. They know the audience they want. So what we tried to do is we tried to watch videos again. Makes total sense, right? We built a much more simple tool here. Because we essentially wanted to assess brand preferences, we would give this tool to one of our internal reviewers who was an account executive or an account manager for a particular campaign. In this case, it's MYB base Q3 2018. I don't even know what that is. We'd ask them a simple question. Is this video highly relevant for this campaign? Is this acceptable, or is this not relevant? And they'd answer a bunch of these videos, and this would help give us, again, training data to figure out whether a video is relevant or not relevant for a given campaign and a given customer. And so really what this did, just like brand safety, is it presented a way to assess the quality of any particular way of serving videos for a campaign. So we have two. We have packages. These were sold via packages, so people selected specific packages. And then we also learned using machine learning to figure out if a video should be in or out, using the reviews and standard cross-fold validation, so this is actually unbiased. The features were almost the same as brand safety. So the representation of the video to solve this problem, which is fundamentally different, is similar. And this is another common theme, is that when you have common business objects shared across different problems, it's very frequent that the representation that's appropriate to solve those disjoint problems is actually shared. So one of the only things that we changed here was we changed from one-hot encoding to mean target encoding, which actually helped quite a bit. It's a different way to encode categorical variables that allows a simple linear regressor to be expressed in the features. Very nice, you guys should check it out. And we didn't threshold, because we didn't know how big these campaigns should be, so we just looked at average precision. So here is the average precision difference by campaign. So on the x-axis is various campaigns between packages and our machine learning method, a drastic improvement. And here's the percent, not percentage, percent improvement. Again, really, really powerful, really big. And now this is not quite in production yet. It actually went in production when I've been in Europe, so I'm excited to go back and see how it is, how it's doing. But again, the business is very excited because I started with a very simple premise, and that is we were not measuring how good the videos were that we were delivering. We focused on one specific number, in this case precision, because what we want is precision is, given the fact that an algorithm identifies a video as good, how accurate is that? Right? True positives over total predicted positives. And once you convince management that this is how you say how good your algorithm is, you can constantly iterate on that. And so this allows us to constantly improve in a way that's unbiased. I'm not injecting my own bias. I've merely convinced them the right way to measure it, and if packages were better, packages were better. Turns out they're not, but they could have been. So the last thing that I want to talk on is our journey through data science architecture. And I should say this is probably what I personally am most passionate about. I love productionalizing machine learning systems. I love it so much that I've helped build a open source machine learning platform. You guys can check it out. It's called Aloha. It's currently on eHarmony's public GitHub. It's written primarily by Ryan Deek, who used to work with me at eHarmony, now works for me at Zefr. It is a Scala DSL. I love functional programming. And what it is it wraps machine learning frameworks. Right now it wraps two, H2O, which is a Java-based collection of popular machine learning algorithms, and ValpoWabbit, a large-scale linear learner. Actually, ValpoWabbit I find is most useful for contextual bandit learning. So if anyone out there is doing reinforcement learning or contextual bandit learning, I highly encourage you guys to check that out. And Ryan wrote this 4 or 5 years ago, before I even worked at eHarmony, and I've contributed to it since then. And productionalizing machine learning, I'm excited to see, is really becoming more of a field on its own. There's new conferences coming out. In fact, we submitted our paper to a new one in San Francisco this year and got accepted. So you guys can read about Aloha in SysML. It's just a couple pages because it's a brand new conference, but we were pretty proud of that. And so what I'm going to do is do a dive into how Aloha works and why it's cool and why you guys might want to use it. So we have two different user profiles to consider when we're thinking about Aloha: the data engineer and the data scientist. The data engineer's job is simple. He wants to get a business object, a video Avro record. He wants to do machine learning. He or she then wants to get a score that says, is this video safe or unsafe? Pretty simple. So what we're going to do is we're going to step through a type-safe declaration of what that might look like. So we have a specific example of type A, in this case maybe a video Avro record. The data engineer wants to pass it through a function that transform it from a video AVR record to a Boolean, and then he wants to do something with the Boolean. That's it. That's all the data engineer wants to do. There's no machine learning here. There's no featureization here. Nothing. To make this happen, the data scientist does have to do some more work. So as a data scientist, when we think about machine learning, we start with a list of type A. This is a bunch of video AVR records. They've been stored in some offline format. What we then do is featureization. So this is the act of extracting information from that object, that business object, and transforming it to an input format that's legible by common machine learning frameworks. CSV format, libsvm format, VW has its own format. And this is really, you can think of a set of functions. So this is a set of functions that go from A to a vector of X, because you might expand multiple features from a single A. In fact, you usually do. So this leads to a matrix, a list of vector of X, right? A list of vector of doubles, a matrix of doubles, for instance, or floats. We're then given some ground truth if we're doing supervised learning. So this would be the real answer. Maybe Y in this case is a Boolean. Is it safe or unsafe? Then we do machine learning. So if you think of machine learning in a functional framework, this is really what it is. Machine learning is a function that accepts a matrix that has examples and ground truth, and generates a function that when given a new set of examples, a new vector of X, it generates a Y. Okay, for all the data scientists out there, you guys do this every day, multiple times a day. This is just written out in functional notation. We're going to add one more component called a finalizer, and this just makes the types line up nicely. It converts Y to B. Frequently, the finalizer is just the identity function. Most downstream consumers can directly consume a Boolean or a double. It doesn't have to be, but generally it is. And really, this is the magic of Aloha, is that it wraps up the act of featureization and the finalizer into one view that's only has two types, A and B. X and Y, totally gone. And this is really, really nice, and has been, and to the best of my knowledge, still is used at eHarmony, and certainly is used at Zefr today. And so if you are in the JVM, specifically if you're in Scala, if you're in something like Spark, if you have a lot of fast features, I would encourage you guys to check this out. But we're actually starting to move away from it, at least on some projects. And this is hard to admit. This is the first time I've actually stood in a talk and gone this far. I usually end with the nice Aloha's fantastic slide. But why are we doing this? Really, the main impetus, more than anything else, was that I just could not hire data scientists or machine learning engineers that loved Scala, that loved type-safe programming as much as I did. Everyone wanted to use R. Everyone wanted to use Python. At eHarmony, this wasn't as big of a problem because eHarmony was a JVM shop. At Zefr, we're a Python shop. So actually, the data science group is one of the only groups that uses the JVM language, which is usually not how it is. So Python was just the natural language. So when I did go out and hire more data scientists, they would do this beautiful R&D in Jupyter notebooks, and then we'd give it to Ryan and say, okay, Ryan, go implement the features that are missing in Aloha, stick it in production. So while the time from training to scoring was beautiful, we have Jenkins jobs that retrain every night and push these models out to data engineering who rescore them on the fly, no one lifts a finger. The time from R&D to training was hideous. And I mean really, really bad. There's another thing that Aloha hides when I talk about it, and that's this idea of fast versus slow features. If all your features are quick to extract, like for instance, you want to just take the number of views that's a double and express it, or one-hot encoding that's quick, no problem. You can do that all at runtime. But if I wanted to take a pre-trained ResNet and run the thumbnail through a pre-trained ResNet to get a dense representation of the thumbnail, that is not very fast, and it requires special hardware. So Aloha wasn't the best fit for that. In fact, we had to do an offline process for computing these. And the tools, like I said, that people wanted to use were, frankly, mostly in Python. Stuff like LightGBM has a Java wrapper. It's not very good. Scikit, obviously all in Python. DocNade is a way to do kind of like doc2vec kind of stuff, document projection, all Python. Glove, you could use that in any language, but really a lot of Python. So we're thinking about a new architecture right now. And here are some criteria. One, we want to use a language that is understood by not only the team, but the community, We want hiring to be easy. We want it to be easy to R&D both new models and new features. We want it to work in a streaming environment that can handle 100 to 120 million unique events a day. And we want to compute features offline from scoring. Here's what we came up with. This is not in production. This is really at the RFC phase, request for comments, but it's inspired a lot by Uber's Michelangelo, which if you guys have not heard of that, I encourage you to go check it out. It's really a nice data science architecture. So let's jump through this. So if we start at the top, we can see we have Kafka. And what we have is a bunch of different types of data coming in on Kafka, some videos, some images, maybe stuff gets replayed. And we have various feature extractors. They can be computed asynchronously and take as long as they want. In addition, maybe we have an offline data warehouse, such as Snowflake, and it emits data every day. Let's say it emits the number of views a video had. And this is useful because maybe a feature is how many views did a video have yesterday, the day before that? These could all be useful features for a problem. So this emits to other feature extractors these offline pieces of information. It all gets aggregated together into a fast storage. Dynamo seems like a reasonable choice here. This is what we use for our image storage now. Whether or not we use Dynamo in the future, I'm not sure. And finally, here's the rest of the architecture. And what you can see is the Dynamo stream flows into a changelog, which flows up into predictors and into models. Forecasting is another type of model we do. I didn't talk about it here. And the features flow to an offline environment for retraining and for R&D. So you can do R&D independently on the features as from the models. And really what this has also precipitated is this moving away from Spark to Dask. I'm very familiar with Spark, in fact, too familiar, and I mean that in a bad way. Spark is a glorious way to write code. You write this beautiful functional code that the types all line up and it flows, and then you hit execute, and oh my God, my container went down, and what the heck's the number of executor cores or executor memory? How do I set that? Oh my goodness, here's all these replays. It's a pain. But it's nice if you're doing embarrassingly parallel work. I wouldn't do machine learning on it, though. Dask is a way to do distributed computing in parallel using Python. It's primarily focused on the data frame API. It's really nice. I would encourage you guys to check it out if you guys are using stuff like data frames and find yourself overflowing one machine. It can also be used on one machine. So let's go into just some brief takeaways, kind of stuff that I've learned that I hope that can help you guys. First of all, streaming beats batch. If you can design a streaming pipeline and you want to go to batch, it's trivial. To go the other way is far from it. Spark tried to do this and still is probably not as good as stuff like Apache Beam or Flink. Better features beat better models. Always go with simple, easy to compute features before you go with fancy deep learning models, and only do deep learning models if that's really what it calls for. Stuff like image processing, video processing, yeah, but tabular data, no. Try and outsource gathering labeled data. This is the first time in my career that I've worked in an environment where I didn't get training data for free. At eHarmony, we'd give out matches, and as the course of using the product, the consumers would say whether they liked or didn't like that match. So we'd have lots of training data. Not so here. Our brands wouldn't even watch training data. We asked them to, they didn't want to. They trusted us to do it, which meant we needed to do it. And finally, don't be afraid to admit when you're wrong. It was really hard for me to do that transition from that nice, beautiful type-safe Aloha diagram to the next one, but it's really unblocked a lot of people on the team. So with that, you can find me on Twitter. Thank you very much.
All right, thank you, John. We have some time for a couple questions. The first one comes from Saba. Do you think it is wise to base the whole product only on YouTube videos? Have you considered working with other video platforms? Also, do you consider using audio of videos for content targeting?
Absolutely. So a couple things. One, Zefr grew up and has had multiple pivots on YouTube. We actually did digital rights management originally, which is finding copyrighted material on YouTube, telling the copyright holder of the existence of that material, and then having the copyright holder take some kind of action, whether to assert ownership or take it down or whatever they liked. So we had this really tight relationship with YouTube. we talk all the time, especially at the executive level, about what other platforms we should target. Couple things. First, yes, obviously we should target other platforms. Two, it takes a lot to integrate with these other platforms. A lot of effort. We want to do that effort, but it's very expensive. Three, YouTube represents about 70% of the advertising dollars spent in digital video. So while we're only on YouTube, it is far and away the whale in the space. And as far as the other part, yeah, we would love to use audios as well as the video. It's just really expensive. And when we're moving into machine learning, we're good enough now, and we really want to focus on solving as many problems as possible before we go deeper down the feature engineering pipeline. But I do think transfer learning and natural language processing is probably a better bet than going down the audio hole.
Sounds good. Anonymous asks, how do you compete with YouTube's own advertising or targeting model, or are you collaborating?
Yeah, we're absolutely collaborating. If YouTube doesn't see us as a value add to the platform, that's bad for Zefr. So we go out and find unique business that YouTube couldn't find. So for companies like AT&T, who don't trust Google to be judge, jury, and executioner, to say, here's your videos, here's how well you're doing, here's what you should do next, trust us. Like, there's a lot of people out there that will just say, no, you can't do all those roles. So Zefr would help fulfill those roles. And at the end of the day, YouTube is really composed of 3 pillars. There's the content creator, there is the brands, and then there's the viewer. YouTube has to be concerned about all of them. If any of those 3 entities goes away, the platform falls down. I, as Zefr, don't care about the people watching the videos, nor the people creating the videos. I am there only to service the needs of the brand. So that's kind of where we fit in the space.
Pewds asks, do you look only into English-speaking videos?
Our primary business right now is in the US, a little bit in Canada. We're actually trying to expand into the EU right now. We're actually debating opening a London office next year because GDPR is just such a boon for us. With most advertisers are terrified of GDPR because audience data is devalued. Well, when audience data is devalued, content data becomes more valuable. So although we're not looking at other videos yet, we're actually spinning up a Spanish-speaking team right now. We've been to the UK, we've been to Germany, we've met with brands like Volkswagen, it's the main one that's coming to mind now, that say you should have a strategy where you do 1 to many lots. So 1 language is English, we've identified the 2nd language as Spanish, many is probably the rest of the Romance languages, and then lots would be kind of the rest of the world.
All right. Anonymous is wondering, do you consider using BigQuery when you opted for Snowflake? What are Snowflake's biggest advantages?
Yeah, so a couple things on this. One, absolutely. We actually evaluated BigQuery in comparison to Snowflake. We found the real reason that we liked Snowflake better was its nice natural support for Avro. So, and I didn't do this work, so I'm not sure about the details, but if I remember correctly, BigQuery doesn't auto-parse Avro formats. And so that meant that we had to write custom parsers, and that was just something we didn't want to do. And Snowflake has auto-parsing, and it's really nice. So that's kind of what we went with. We actually do use BigQuery for some data analytics because Google actually delivers information back to us with BigQuery, but that's not what we're going to use as our main data warehousing solution.
All right, and I think we have time for one last question. Do you mark a channel as unsafe if it contains at least 1 unsafe video?
You guys can read my mind. These are all questions that we think about every day. The answer is no, we do everything at the video level, but a lot of our clients are coming back to us and using phrases like, we don't want to be the only nice house in a bad neighborhood. Like, we don't want to be a good video in a bad channel. So this is actually a real kind of hot topic of how do we translate this idea that a video stands on its own, but is still part of a channel and still an open research question for us.
All right, absolutely. Thank you very much. Round of applause.
Thank you.